Today we're going to start talking about acids and bases. So if you could fill the notes in as we go on your note packet, that would be great. So to begin with, we've talked about what electrolytes are, and electrolytes are any substance that when we take it and we dissolve it in water, it's going to form a solution that can conduct electric current. We talked about how you need to have mobile ions to be able to conduct electricity when you're ionic. We talked about how when you're a metal, you need to have mobile electrons. So here we're going to go further and say that an electrolyte is any acid, base, or salt. And remember that a salt is just an ionic compound. So that's something to keep in mind as we go through. This whole chapter is about acid, bases, and salt, or this chapter is about electrolytes, things that conduct electricity. So I just wanted to give you a few examples of dissociations on the bottom of the page. You see that NaCl, when we put it in water, will break up into Na plus and Cl minus. HCl, which is an acid, will break up into H plus and Cl minus. And NaOH breaks up into sodium ion, Na plus, and OH minus. So here's a typical type of Regents question that asks about which one is the best conductor of electricity. A couple of things we want to keep in mind. One, the best solution will have something that's aqueous in solution. So solids typically aren't the best answer that we could choose. So we look for something in solution, and we look for something that's going to be an acid, a base, or something ionic. Of the choices, NaCl aqueous would be the best answer. Here's another type of similar question. Which species can conduct electric current? So again, we want to look for an acid, a base, or something ionic. And we want to look for something in solution. So I'm going to start by looking at these two that are in solution. We have CH3OH. We see that that's all covalent. Even though it has that OH on the end, it's not going to be a base because there's not a metal in front. So to be a base, we're going to see that we're going to look for something with an OH in the back, hydroxide, but a positive ion in the front. Since this is all nonmetals, it's not going to be considered a base. So our answer is going to be HCl aqueous because it has that H in front, which all acids we're going to talk about will have for the purpose of Regents chemistry, H in the front, and a negative ion in the back. So if you could look on your reference table, here is table K and table L are going to go through the common acids and bases. For Regents chemistry, we don't need to know really how to name them. We just need to be able to come find them if I'm asked for a name. So if I give you the formula HCl, they may ask you what's the name of this acid. You come to table K, you look at the acid chart, and you're just going to write the name. Or I could give you the name hydrochloric acid, and we could say what's the formula, and then you would come here and just write HCl. So table K gives us our common acids. Table L gives us our common bases. The bases have hydroxide in the back. If you see NaOH, KOH, CaOH2. Remember that 2 is there because it was crisscrossed in the formula writing. And all bases will have OH, but a metal has to be in front. Because the idea is that when we put it in solution, it will break up into ions. OH is a negative ion. You need to have a positive ion in front. If I have OH in the back, as in the previous example, but there's no metal, it's not a base. That's just a covalent substance. The last one is something I need you to keep in mind, NH3. We're going to talk a little bit about why that's a base, but realize that that's the only one on the common base chart that doesn't have an OH in the back. As far as the acids, I'd like you to underline right in your table K all the H's in the front. Everyone has an H in the front, except this last one, ethanoic acid. You could circle COOH. That COO group is going to come up again in organic chemistry, but it lets us know that that's an organic acid. So we're going to need to identify acids with either an H in the front or a COO in the back. Next question asks us which one is a non-electrolyte. A non-electrolyte means it doesn't conduct electricity. So that means it's not an acid, it's not a base, and it's not something ionic. So if we look at these choices, we see that NH3 is on the common base chart, HCl is on the common acid chart, KBr is ionic, so our answer has to be choice 1 because it's not an acid, not a base, not a salt. Again, it's not a base because even though it has this OH on the end, there's no metal on the front to make it be able to dissociate when we put it in water. We know that some acids are stronger or weaker than others. So if an acid, when we put it in water, completely breaks apart, meaning it goes into its positive and negative ion completely, and is often irreversible, that's going to be a strong acid. Weak acids are those that are only partially or reversibly dissociate. So the ones that you have to know as far as strong acids would be hydrochloric acid, nitric acid, sulfuric acid. The ones listed here, for Regents chemistry, we really don't have to know much about the strength of acids, just that the stronger ones are typically on the top of table K. Same thing with bases. The stronger bases are on the top of table L, if we go back here. So HCl is a strong acid at the top. Acetic acid is a weak acid. On the base chart, sodium hydroxide is a strong base. Ammonia would be a weak base all the way at the bottom. So over time, different scientists have had to, or tried to classify what an acid or base is. One that we need to know for Regents chemistry is Arrhenius. Arrhenius says that an acid is anything that yields hydrogen ions as the only positive ion in solution. So that means that not everything that has hydrogen, like for example CH4 has hydrogen, but it doesn't produce hydrogen ions when I take it and dissolve it in water, because it's something that's covalent, it doesn't ionize out. But anything that produces hydrogen as the only positive ion, so here we see that when hydrochloric acid dissociates, hydrogen is the only positive ion, that means it's an Arrhenius acid. When we take hydrogen though, and we put it in water, it's going to form the hydronium ion, H3O+. H3O+ is listed on your reference table on table E as hydronium, so you don't have to memorize the name, but it will be coming up over and over throughout this unit, so it's something to recognize. Hydrogen, when we put it in water, a hydrogen ion in water becomes hydronium. And the last thing I want you to know about acids is that organic acids have this Cu group, and the Cu group also produces hydrogen ions as the only positive ion in solution. That's why that's still considered an acid. So here's a picture showing you if you take an acid and you put it in water, it will break up into these H+ ions. The same works for bases, but a little opposite. Bases, when we put them in water, they're going to produce hydroxide ions. I just wanted to show you a visual of what's happening. Acid, the only positive part is H+. Bases, the only negative part will be OH-. So this one is asking you which one is classified as an acid. Open up to your acid chart. We're looking for something with an H in the front. We have HF as our second choice. Notice choice 4 has an H, but the H here would be negative. We're looking for H to be positive when you're an acid. In HF, H would be positive, F is minus if we look at oxidation numbers. LiH, Li is +1, so here H would be minus when it would not be an acid. So the answer was HF. This one asks which one is an Arrhenius base. A base is going to have the OH in the back, so choice 3 and 4 have OH in the back, but it has to have a metal in the front, so it's going to be choice 3, KOH. What is the only negative ion in Arrhenius base? Bases have hydroxide, so choice 2, OH.